Let's start with linear functions. What's a linear function? Oh, yeah. Yes, that's exactly correct. Can we expand on that? We need to kill that fly, okay?
It's very distracting.
Yeah,
It's a thrasher fly.
yeah, it's finna die. You were close. Get some chopsticks. Yeah. All right.
Somebody can do that.
If you can do that, why let me know, right? Okay, it's a function. This is pretty much what she said. Okay, what she said. A function whose graph is a line. Yeah. Okay. Now it has certain traits, right? Like what makes it a line instead of a parabola? Okay, it's straight. What about the function makes it a line instead of a parabola? It's what? It's right. It's one. It is 1-to-1, but on this, what keeps that going straight and not curved? Constant would be B. X's are having a power other than 1. The highest power of X is 1. That's what makes it part of the linear family. Once we get to messing with the X, that's what starts curving our line. Okay. Let's see. While we're here, what's that? That's the slope. What's that? Yeah, that's the y. Right. Okay. And what is slope? Rise over run. Okay. Slope is rise over run. Slope is the change in y over the change in x. The big boys and girls now. So we're going to see this. Delta y over delta x. Delta means change. Okay? So if you see this triangle is a really fast way of saying this. Okay? The change in y over the change in x. Delta y over delta x. Formula for slope, y2 minus y1 over x2 minus x1, because it's a change. You're trying to find out how much something has changed, you find the difference between the two, and difference is subtraction. Remember how to find slope. I'm going to give you an example. Alright, so find the slope. Let's see. I'm just going to make some up. 2, 4, and I don't know, 11, negative 3. And let's see. Alright, there you go. Okay, so for problem A, what would this look like? Set this up. What do I get? Negative. Okay. Alright, what does this one look like? Yeah, negative 3 minus 6. negative 9 over 3, negative 3 over 1. Okay. And then, how about this one? Negative 1. Alright. All of these are negative, meaning they're decreases. If you graph them, what would they look like? What does a negative slope look like? Yeah, like this. That's when m is less than 0. If m is greater than 0, and it increases, it goes up. Right. Another term for slope is rate of change, and like this one, you can really talk about rate of change because you have, like this is, you are losing 1,250 people per year. So that's a rate, like something is happening, when you use that term per, whatever, that's a rate, okay? And you should remember that, like, that's what they're doing in Amory's math class right now, they're doing rates, and so we've been talking about that at night. This is what's happening, like they are doing sodas and apples and stuff like that, but this is a rate of change, because it's how much you're losing each year. You can talk about like the temperature and how much it increased per hour or whatever. So that's a rate of change. Alright, so let's talk about a couple of forms of the line. We've already talked about slope-intercept form. So we'll just review that real quick. Slope-intercept form is that y equals mx plus b, and it's called that because you have the slope and the y-intercept. See, we're not really creative math people. It is what it is, okay? So, this is your slope, m is your slope, and b is your y-intercept. And tell me again, what's the y-intercept? Yeah, where it crosses the y-axis, exactly. And then the other one is point-slope form. Point-slope form is pretty useful. If you have a point and a slope, it's really useful. Alright, I'll write it down and we'll talk about it. Usually in x1 and y1 is your point. Right. And then just looking at. So usually in pre-calculus down, okay, all the algebra-based, trig-based classes, okay, point slope form is a means to an end. Usually we get to here so we can get to there, okay? Next year, for those of you who move on to calculus, this is it. Once you get to point slope form, you're done. Walk away from the problem, okay? This year, continue to here, okay? And just think, next year I'll be done by this point. Well, it's not next year, so get to here and then get to there, unless you're told otherwise, okay? But in calculus, on the AP exam, they don't really care where you go. If you get some form of the right answer, they're happy. But if you get some form of the right answer and then you mess up, you lose all your points. So once you get some part of the right answer, for those 4 of you who are going on calculus, all right? Okay, constant function. Constant function is just y equals a number, just like your y-intercept. There's no slope. Okay, that's a constant function. Graph, it's a horizontal line. People are like, oh, it's a straight line. They're all straight. That's why they're lines, okay? They're all straight. This is a horizontal line. to give you some, and I'm going to let you find the slope and the y-intercept. Slope on number 1. Alright? What's your y-intercept? Okay, what's the slope on number 2? Really? Negative 1/2. Yeah, that's just 3/4 minus 2/4 x, which is the negative 1/2 x plus 3/4. Alright, how about this one? Oh, I didn't do that one. I'm funny or dead. No big deal. What is this factor to? So those cancel out and are just left with x plus 2. You do have a hole in the graph at 2, but your graph is the linear function of x plus 2. You can find a hole at 2. So what's your slope? What's your y-intercept? Yep, that's the hole. So when you graphed it, it would look like this. So average rate of change. Remember average rate of change? Okay, average rate of change is a slope. It's the slope of a secant line. Secant line means that it touches the graph in 2 places. Yeah, okay, so like, let's say you've got a graph, some crazy graph, right? And this would be A and F of A, and this would be B and F of B. So you would find the slope of the secant, and that would give you your average rate of change. Okay, and it's just the change in the function over the change in x. But we've done that already, so that shouldn't be anything new. Now the difference between an average rate of change and an instantaneous rate of change. There is a difference. Instantaneous rate of change tells you the slope not from here to here, but at any point along this graph, okay? But that's calculus. In fact, that's almost the entire study of calculus, is that instantaneous rate of change. It is like the central theme of calculus. That's what we try to find out, instantaneous rate of change. And that's like your car. Like if you get stopped by the police for speeding, and they're like, you're doing 70, you can't be like, well, I was doing 40 back there, so it averages out. No, you're getting a ticket, okay? Because they go for instantaneous rate of change, where everything that we do up to calculus is an average rate of change, okay? So even though we do all these problems with speed and all that, it's not really that. Anyway. All right.